Welcome to this third video lesson on work, energy and power. In this video lesson we're going to focus on kinetic energy, which is the second type of energy that we are required to do in this course. So we've learnt about work. Work is basically the transfer of energy from an agent to an object through a force. So we worked with the formula work equals force times the distance that the object is moved by the force. Then we looked at gravitational potential energy, EP equals mgh, where that is the ability of an object to do work due to its position in a gravitational field. Today we're going to look at kinetic energy. So kinetic energy comes, the word kine comes from the Greek word kine means motion, it means to move. So if we look at the definition of kinetic energy is the ability that an object possesses to do work due to its motion. Now, we are not going to derive the formula for kinetic energy. We'll do that in grade 12, but we will just use the formula and we can then look at it and get an understanding of what contributes to an object's kinetic energy by considering the fact that first and foremost the kinetic energy equals the half. Don't worry about where the half comes from. The half comes comes mathematically from the derivation. It's to do with an equation of motion for velocity that is used in the derivation. So the kinetic energy is half times the mass. So the fact that the object has a mass means that when it's moving, it's going to have kinetic energy. But the most important thing is that the object's kinetic energy comes from the velocity, and notice it's the velocity squared. So it's the speed that is the biggest contributing factor. So you can have a small mass that is traveling at a very high velocity or speed like a bullet, and it can do a lot of damage because of its high kinetic energy, which comes from the fact that it has a high velocity. The formula that we use is EK equals a half mv squared. Some textbooks also use KE, and advanced textbooks even use T. But we're going to use E subscript K. The E, capital E is energy, and the K is the type of energy. So if we look at the formula triangle, we see that EK equals half times the mass times the velocity squared, where the vertical lines represent multiplication and the horizontal lines represent division as before. The units for kinetic energy are the same as for work and for potential energy. We are going to work with speed in terms of meters per second, and mass is going to be in kilograms. So let's look at the first example. Determine the kinetic energy of a motor car with a mass of 900 kilograms traveling at 50 meters per second. So we're looking at this example here. So the solution would be, first step, we put down the formula for kinetic energy, half mv squared. We then substitute for the mass 900 kilograms and for the velocity 50 meters per second squared. That's 1 mark. And when we work that out, we get 1,125,000 joules. Now remember, 1 kilojoule is 1,000 joules, and 1 megajoule is 1 million joules. So this, if we wanted to describe it in terms of megajoules, we could do that. We would divide by a million and we get 1.125 megajoules. So kinetic energy is the measure of how much work an object can do because of its motion. So let me give you an example. So let's say, for instance, we've got a truck that's rolling down an incline, but it's a very slight incline. It's rolling down and it hits a wall. It's got a very low speed, but it's got a big mass. Well, that would still do a lot of damage because the kinetic energy is massive because of the mass. And because it's got kinetic energy, it's got the ability to do work on the wall, namely push the wall over or damage it. Let's take a bullet. It has a small mass, but it has a very high velocity, and we know because we square the velocity, it can do a lot of damage. Now, associated with kinetic energy is the idea of mechanical energy. Now, mechanical energy is when you take the kinetic energy of an object and you take the gravitational potential of energy of the object and you add them together. So some people would talk about the total energy, but we're hesitant to use that term because total energy can also include other things like sound energy, light energy, heat energy. So mechanical energy is the sum of the kinetic energy as well as the gravitational potential energy. So there we use the subscript m for mechanical energy, so it's E, capital EM. And so here we have an example that I would like you to try, seeing that we've now done kinetic and potential energy. It says determine the mechanical energy of a drone with a mass of 2 kilograms flying at a height of 6 meters above ground level at a speed of 3 meters per second. So I would like you to pause this video now and give that a go, and then we will look at the solution once you have done it. So now let's take a look at the solution. So in order to find the mechanical energy, we need to find the potential energy and the kinetic energy separately and then add them together. So the drone has a mass of 2 kilograms. Has a mass of 2 kilograms. So there's our drone, however it looks. I'm now drawing it like a small aeroplane, but it's probably going to be more like a quadricopter, like that, with little blades like that, little rotors. So let's rather go that route. And we're told that it has a mass of 2 kilograms. And it's at a height of 6 meters. It's a height of 6 meters. So we're going to define the ground as 0 meters, and therefore the potential energy on the ground will be 0 joules. So at this point here, the drone has a potential energy of 2 kilograms, so it's mgh, 2 kilograms. Now, okay, we've used 10 here, but we are going to use 9,8 meters per second squared, or newtons per kilogram, times the 6 meters. So that's going to give us 2 times 9,8 times 6, and that's going to give us 117,6 joules. So that's going to be the gravitational potential energy. Let's say that's 3 marks. But now it's traveling at a speed of 3 meters per second horizontal to the ground. So it's traveling like that. Its velocity, we use v for velocity. There is a slight difference between velocity and speed, but for grade 8 we assume that they're the same thing because we are working with things only moving in a straight line. As soon as something changes direction, the velocity and its speed become different. So this is 3 meters per second. We want to work out the kinetic energy. It's a half the mass, which is 2 times the speed squared. Don't forget the square. It's a common mistake to forget the square. So half times 2 is 1, and 3 squared is 9. So the kinetic energy is 9 joules. So that will also be 3 marks. And now what we're going to do is we're just going to add the 2 together. And so we therefore get that the mechanical energy is 129 joules. So because that quadricopter, that drone is flying at 3 meters per second at a height of 6 meters, that means that it's got motional energy and it's got potential energy. So if this drone now falls down, it's going to land and it's going to do work on whatever it lands on, but because it's got a speed of 3 meters per second, it's going to do even more damage because it can do extra work due to its motion. So now let's move on to the next problem. So in the second example, we are going to work with bigger values, and you're going to see that it's going to result in an object, in this case a plane, having a massive amount of energy, mechanical energy. So we have a plane, it's flying horizontally at 250 meters per second. It has a mass of 2.5 tons, and it's flying at 8.5 kilometers above ground level. So the question asks, calculate the mechanical energy of the plane. So we are looking for E mechanical, which we represent with EM. So we are going to firstly need to work out what is the gravitational potential energy of the plane, what is the kinetic energy of the plane, and then last but not least, what is the mechanical energy of the plane. So I'm going to ask now that you pause the video and you give that a go, and then when you're done, you can press play, and then you will get the solution. So the first thing we need to do is convert the mass into kilograms. So we're going to say, well, this is the equivalent of 2,500 kilograms. We have multiplied 1 ton by 1,000 kilograms. And we need to, the height we need to convert to meters. So there 2 kilometer or kilometer is 1,000 meters. So the height is going to be 8,500 meters. The velocity is fine, it's 2 meters per second. So now we're going to work out the potential energy. So the potential energy is going to be, and I'm going to open it up here, it's going to be mass times gravity times h. So that's going to be, the mass is, we worked it out to be 2,500 kilograms. There we go. The mass is 2,500 kilograms. We are flying near to the surface of the Earth. So G is going to be 9,8 newtons per kilogram, and the height is going to be 8,500 meters above ground level. So now, using our calculator, we work out that the potential energy is going to be 208,250,000 joules. That's a huge amount of energy because of its position above the Earth's gravitational field. So that would be, dividing by 1,000,000, that would be 208,25 megajoules. Well, let's now look at the kinetic energy. Well, the kinetic energy is going to be a half the mass times the velocity squared. Well, we know that the mass is 2,500 kilograms. But now the velocity, if we look at the speed, the plane is traveling at 250 meters per second. So we're going to work that out. So we go 250 meters per second. And a common mistake is that learners don't square. They forget the square. Okay, so let's do that. So we go EK equals 0.5, a half, times 2,500 times 250 squared. And we get another big number. So this is going to be 78,125,000 joules. 78,125,000 joules. That's the equivalent of 78,125 megajoules. And so now, to work out the mechanical energy, we add the 208,250,000 joules and the 78,125,000 joules, and we get a big number. So that's going to be plus and that gives us an amount of 2,286,375,000 joules, which is the equivalent of 286,375 megajoules. And so with that, we now end off this video lesson. In the next video lesson, we're going to look at the principle of conservation of mechanical energy. And we will look at problems that we will need to solve in systems, in more complicated systems where the objects are changing height and changing speed, and using calculations together with conservation of mechanical energy, or what we call the principle of the conservation of mechanical energy, we will be able to solve them.